Okay, online lecture number 2. Today we're going to talk about geographic analysis. So last time we talked about geographic basics, and it was just about layering. How to make a map, we needed to add multiple layers together. Now let's start asking some questions of that data and taking a look. So a pretty common map type that you're used to seeing is where each of the states or each of the counties is colored in with some value. It's called a choropleth map. That's what we're aiming for. So the what here is the geographic analysis. The point is that we're trying to see how data is related geographically. We want to see these things in relations to others. Where are things greater than others? Where are things less than others? Is there a spatial pattern to it? Is there something that we can predict with this? Why we're doing this? Much of the data we interact with is spatially oriented, or it's related to geography in some way. Particularly, well, actually really anywhere. I was going to say particularly in the United States, but really anywhere. There's a spatial component to what's going on, and there's a spatial component to news. So location matters. What we think about, where is it in relation to me? Where is it in relation to my family, where I live, what city I live in, what state I live in? We all want to care about that. So the hard part about this is that spatial data is really complex, and spatial queries can get pretty hairy pretty quickly. But luckily, much of what we have done so far this semester is perfectly suited to what we're going to be doing here. So the how I'm going to show you in a screencast, and we'll do that right now. Okay, so we're going to try and make a choropleth map out of what we did in the last assignment. So I've got all of that code loaded up here. You should have it laying around from the last time. So let's go ahead and get this rolling, where I'm going to load all my libraries. I've got the tidyverse, I've got simple features, I've got janitor and scales. I may not need all of these. Scales, I don't think we loaded last time. Scales is a library that'll come in really handy here in a bit. You should have it installed already. If not, you know how to install it. Just go to the console, install packages, scales. It's pretty easy. So let's load up this hospital data, and because I'm in a file that hasn't been saved yet, I need to specify the book projects, data journalism R, there we go. So there is my hospitals data. I'm going to go ahead and filter out Nebraska hospitals. Then I'm going to go ahead and filter just critical access and general acute care hospitals that are open, just like that. I'm going to go grab counties, and this one I'm going to adjust the data journalism R. There we go. And now I've got all of the counties. I can filter out Nebraska counties just the same way using the state FP and 31. So there we go. So now I have all of my basic data up here set up, where I have the 90 hospitals, sort of general hospitals that are open in the state. I've got my counties, the 93 counties. So a simple question to ask is, how many counties, or how many hospital beds are there in each county? And this is truthfully the most optimistic number possible. This is not asking, are they critical care beds? Are they ICU beds? Are they even staffed? That's another question of whether or not even some of these beds could be used. This is literally the best case scenario for the number of beds possible in a county in the middle of the COVID-19 crisis. Well, luckily we've got everything we need to be able to do that. So we take our hospitals data, we're going to group it by county, and we're going to summarize it up, creating something called total beds, and we're just going to sum the category beds in our hospital data, and it should tell us. Now, there we go. So Adams County, 161 total beds in Adams County, but notice we get this geometry that goes along with it. Here's the thing, with these aggregate queries that we've done, this geometry column now becomes pretty much useless, because what did we have before? Well, we had points. So if it's merging all those points together, it's not really telling us anything. So this is kind of useless, and it's going to cause us problems later on. So we need to get rid of it. The way that we're going to do that is a little bit involved. But really, every step is pretty simple, and it makes sense once you put it all together. One thing to notice real quick is if let's just look through all of these 63 counties. If we go here to the end, Thurston County has negative 978 hospital beds. The problem here is that when the Department of Homeland Security doesn't know, and I'm getting notified that I should walk my dog. I'm going to go ahead and turn that off. That won't be the last time that happens. Getting back to where we were, Thurston County has negative 978. When the Department of Homeland Security does not know, they record it as negative 999. That's fairly common in a lot of data sets where an unknown value gets recorded as like 5 nines or negative 999, and it's just the indicator that we didn't know we needed to record something the way that we were recording the data required some sort of data entry, and we just wanted to signal to you that this is bad data, we don't want to use it. So we've got to filter that out. So clearly, if we want to do this correctly, we need to filter that out, or it's going to create a really weird value in Thurston County. So first thing we need to do is we need to convert this into a data frame. We need to get rid of Thurston, that negative 978 or the negative 999 value in Thurston County and anywhere else that it might happen, although it hasn't happened anywhere else in the states, just Thurston County. We're going to group by the county and the county FIPS number, which in this case, if we look at our Nebraska hospitals, the county FIPS number down here is actually a 5-digit number, which is really not the county FIPS. The county FIPS is only the 3-digit 001 in this case. 01 is the state FIPS, but in this data set, they merged the two together, which in census parlance is something called GeoID, which we can look at if we look at our hospitals, our Nebraska counties. Here is GeoID, and you'll see there's 001, 01003. So we're going to make these match up because we're going to join this data together. So that's something that we need to do. So we're going to join by the county, or group by the county and the county FIPS. We're going to summarize the total beds. We're then going to use rename to rename county FIPS to GeoID. Rename in the tidyverse is a little bit backwards in my opinion. This is the thing you want it to be named, and it's set equal to this is what it is. So it's what you want it to be equals what it is. And then we're going to remove the geometry column entirely, because if we didn't do that, when we went to join, it would be included in there, and we don't want that. So if I go ahead and run this, you'll see that over here I now have a NE bed count, and if I open that up, you'll see I've got all of what I thought I would need. Adams County, Nebraska's FIPS code is 31001, so that's the first county in the state is Adams County. There's 161 total beds. I can scroll through here pretty quickly and see I don't have any negative numbers. Thurston County now has just 21 hospital beds in it, aside from the one that is unknown. So that's all pretty good. That's looking like we want it to be. So now what I want to do is I want to join that data to my county's data. So I'm going to create a new data frame here called Nebraska Hospitals by County. I'm going to take my counties file with 93 observations in it, so 93 counties, and I'm going to left join Nebraska bed count, the data that I just created, and I'm going to use by GeoID. So it's going to join all of the data in my Nebraska bed count to my Nebraska counties, and it will keep all of the Nebraska counties. It's the left join. So all Nebraska counties gets kept. Left join means I'm just going to merge where these are equal, and GeoID is a pretty good way to do that because they're unique to each county. So this warning here is nothing. We can ignore it. Somewhere along the way, something got turned into a vector, and we just are merging it by characters anyway, so it's not a big deal. Okay, so now we have a data frame called Nebraska Hospitals by County. It has every county in Nebraska in it, but it also has this bed count in it. So we have everything we need to make the map. We do that with ggplot. We just create a canvas here, and now we're going to do geom_sf, same that we've been doing, where I'll do data equals Nebraska hospitals by county. And the aesthetic here, we're just going to change the fill to total beds. And I had this theme minimal here just to remove some extra cruft from the map. So when we run that, this is what we get. Immediately, you might be thinking, ooh, we actually got something and it looks like a map. And, you know, not surprising that Omaha here, this would be Douglas County, has the most beds. I mean, that's where the most population is, and Lincoln would be second. The problem is all of these counties here that have this dark blue shade are all sort of in about the same range, which with this range here, it goes from 500, it's in 500 bed increments. Well, there's only 2 counties in the whole state that have more than 500 beds, period. So this doesn't work all that great for us. And this is where the scales is going to come in pretty handy. We're going to add something called scale fill viridis, which is going to change the colors of these to be a little bit easier to separate them apart. Scale fill viridis C has, oops, that's not right. Did I do that wrong? Hold on one moment. I might have copied something. Oh, I guess it is. I didn't notice that before. The scale fill viridis _C has a couple of options. This is the option plasma is just sort of the colors that it's going to give it. And the transformation here to the square root, it's going to make it an exponential curve. And so when we do that, we get a little bit more of a gradation between very, very small hospitals and something a little bit larger. So things like Grand Island pop out a little bit, Scottsbluff pops out a little bit, North Platte pops out a little bit. Omaha jumps off the map because, well, it should. They're the most hospital beds in Omaha and Lincoln, which kind of jump out here. Which actually got me thinking was, how many hospital beds are there in Omaha and Lincoln? And if you look, Douglas and Lancaster counties, there's 2,400 hospital beds, almost 2,500 hospital beds in Omaha, and almost another 1,000 in Lincoln. And so you've got 3,500 beds or so in Lincoln and Omaha. What about the rest of the state? Well, we can actually figure that out. So we can filter out Douglas and Lancaster. So give me counties that are not Douglas and not Lancaster. So the ampersand here means and. So give me every county that's not Douglas and Lancaster County, which is pretty much all of them, except those 2. And if we do that, there's 2,586 beds in the rest of the state. There are 6,049 total. So we can use R as a calculator here and do 2,586 and 6,049. That means that there's 43% of the state's hospital beds in 65 counties. And there is the remainder are in 2 counties. So it's 57% of the state's hospital beds are in Omaha and Lincoln, which is very far on the eastern side. So not a lot of geographic distribution of this resource that hopefully we aren't going to need, but I got a bad feeling that we are. That's a basic introduction to it. Look in the book. It goes a little bit further. There's stuff in this that will help you with the assignment. There's stuff in the book that will help you with the assignment. So check them out.